Hello, welcome to Math 230. I was reading my book, The Cartoon Introduction to Calculus, the other day, and I was remembering how each of you, because you've been through the first semester of calculus, has already climbed Mount Derivative. So this was a steady uphill climb, but you did it. You've spent 4 months learning about derivatives, what they are, how to find them, how to use them. And at the end of Calculus 1, you learned that calculus is actually about two mathematical mountains. Mount Derivative, which we spent a lot of time on, but then you were introduced to Mount Integral. And these two mountains have a very special relationship, which is encapsulated in the fundamental theorem of calculus, which is one of the greatest ideas mankind has ever come up with. And so now that you're proficient on Mount Derivative, this semester we're really going to tackle Mount Integral, and we're going to see a lot of the wonderful things that this tool can do. And I want to be upfront. This was a climb, this was a good hike, but guys, this right here, it's pretty intense. And Calculus 2 is considered the most difficult of the traditional three calculus courses that are taught. There's 1, 2, and 3, and it is Calc 2, Math 230, that is usually the most difficult. So, but we're going to be ready for it. We've got our foundation, and we know what we're in for, and it's going to be a pretty exhilarating climb. Okay, so I'm about to read to you 4 pages of some quotes, all one long quote, but which I normally wouldn't do, but this is so fundamental to our semester and the background of it that I felt like it was necessary. So before Newton and Leibniz even discovered the fundamental theorem of calculus, Fermat and Descartes had discovered how to use algebra to find the maxima, minima, and tangents of curves. You've seen all that in Calc 1. What remained elusive were the areas of curves, or more precisely, the areas of regions bounded by curves. People were having a hard time figuring out this piece of the puzzle. And to be fair, no one in reality realized that these two pieces of the puzzle even went together. The area problem, classically known as the quadrature or squaring of curves, had consumed and frustrated mathematicians for 2,000 years. Many ingenious tricks had been devised to solve particular cases, from Archimedes' work on the area of the circle and the quadrature of the parabola to Fermat's solution for the area under the curve y equals x to the n. But what was lacking was a system. There was no unified way to find area under a curve. Area problems were tackled on an ad hoc basis, case by case, as if the mathematician were starting over each time. Imagine having to invent calculus each time. The same difficulty beset problems about the volumes of curved solids, we'll see these, and the lengths of curved arcs, we'll see these this semester. Indeed, Descartes thought arc lengths were beyond human comprehension. Not true. We're going to understand this semester. In his book on geometry, he wrote, "The ratio which exists between straight and curved lines is not known, and even cannot, in my judgment, be known by man." So he was pretty smart, but he was wrong about this. All these problems, areas, arc lengths, and volumes, required infinite sums of infinitesimally small pieces. In modern parlance, they involved integrals. Nobody had a surefire system for any of them. Now, the really miraculous resolution of all this mathematical frustration. This is what changed after Newton and Leibniz, so our inventors of calculus. They independently, so each of them discovered this on their own, discovered and proved a fundamental theorem. You saw this theorem at the end of Calc 1 that made such problems routine. The theorem connected areas to slopes. This is totally innovative, and thereby linked integrals to derivatives. It was astonishing. Like a twist out of a Dickens novel, two seemingly distant characters were the closest of kin. Integrals and derivatives were related by blood. And this is Stephen Strogatz, a mathematician, in his book Infinite Powers. This is what we're going to see this semester. We're going to see how derivatives actually help us find areas under curves and volumes of curved objects. These are two things that nobody really imagined would go together, but Isaac Newton and Gottfried Leibniz discovered that they actually do. Okay, so let's talk about our typical Math 230 routine. There are so many different topics, over 20 different topics that we need to cover in this course, and you're initially going to sort of get a foundation, some mental maps through watching a video and taking a quiz on that video. So this is the initial exposure to the topics, the material. And then there's two pretty important types of assignments. You'll see one called Delta Math. These are online problems to gain fluency in a certain technique. There's lots of different techniques in Math 230, and we need to become proficient at all of them. And so Delta Math, it's a nice software tool that you can keep practicing until you get 100%. So this is a great way to practice those topics that we're learning. We'll also have, of course, handwritten assignments, and we'll talk more in class about this. We're going to have A and B assignments. These are longer problems that are going to get us ready for more exam-like type questions. Also in class, we will do several problems like at the board with teams and with pairs. Some problems you'll do on your own in class, but we're going to treat class time as not only reinforcing material, through the things that I'll say, but also a lot of practice with problems. At the end of each module, we will take an exam practice problems quiz. This will help get you start getting you geared up for the exam, and then we take a midterm exam. As far as grades and how grades are calculated, the assignments, the quizzes, the in-class work that you'll do will count for 20%. We'll take 3 midterm exams, and those 3 all combined will count for 55% of your grade, and then the final exam will be 25% of your grade. So you can see that exams are the majority of how your grade will be calculated. This right here is sort of the field work, the training to get you ready for those exams. So you want to put forth your best effort in these assignments. Just like training for a marathon, you don't want to show up to the finish line or to the start line and not be prepared. And these are all of those, workouts, all of the ways that are going to get you prepared for the exams. The letter grade at the end of the course is calculated by a pretty standard, A, B, C, D, F as listed here. So one important policy to know about is there's no late homework accepted in this course, but I also understand that emergencies come up every semester, whether it's car trouble or illness, so I will not take any late homework for any reason, but at the end of the semester I'll drop your 3 lowest assignments, and that'll compensate for any emergencies that you may encounter during the semester. And so just whatever your 3 lowest scores are, we'll count those as if they don't count towards your grade. So we want everybody to be as successful as possible this semester, and Math 230 is a challenging course with a lot of really dense topics. So some ways to get help is, well, first of all, be in class every time and on time. There's no substitute for the things that you'll learn during the class time. Another place that you can get help is the Math Tutoring Lab. So at CGCC, in your tuition, you've already paid for it. You have free tutoring. You can drop into the Math Tutoring Lab. And if you're on Pecos, it's on the 2nd floor of the library. If you're on Williams campus, it's in Bridget Hall 115, or also online. If you're in Canvas, on the left side of your screen, there's a button that will take you to actual CGCC tutors that are just online. And so if you're not able to make it to campus, that's another option. This is a good place to get questions answered. You don't want to be completely frustrated. These assignments are going to take time, but it's totally okay to reach out for help at any time. The best practice is to do all you can on your own, and then go to the tutoring center, whether it's on the 2nd floor of the library at Pecos or in Bridget Hall on Williams or online, and ask questions. The tutors are pretty good about not just giving you the answers. They will help you think through the logic of it. But you don't want to go to the tutoring center too soon. So you do want to really think through the problem, try your best, try your hardest on your own. But don't think that it's going to be difficult to get through this course with no help and just on your own. So reach out to help. Also throughout the semester, I'll give some good online, there's so many good YouTube calculus videos out there, and so we'll talk about those also. You can always message me on Canvas. I receive Canvas messages pretty quickly, and I try to respond quickly. I do get them quicker than email, so my preference is to have you message me on Canvas. The textbook that we'll use is called Active Calculus. The author is Matthew Bolkins, and it is online for free, but we are going to use the 1st edition, not the 2nd edition, which just came out. So just search for Active Calculus 1st edition, and be sure you're using this edition so that you're on the same sections that we're on. So we're just going to keep in mind that Math 230 is a 5-credit course. That is almost double what a typical college course is. So you really want to hit this course from the beginning, being very organized, very engaged. The course moves pretty quickly. So just a few things about me. I went to Brigham Young University for my undergrad, and I studied math there. I then went to UCLA and got a master's degree, and I studied math again. Calculus is one of my favorite courses to teach. I feel like it is the grand narrative in mathematics. It's a story more than any other math course. We have a sort of beginning, middle, and end to this story, and it's really just a topic that keeps on giving and giving. It made the modern world possible. Without calculus, we simply wouldn't have so many of the things that have made life easier and better for us. So I'm looking forward to a great semester.